Okay, let's solve the equation sine of 3x times cosine x equals cosine of 3x times sine of x. Okay, so I'm going to end up using the identity here, the product sum identity, sine of theta cosine of phi equals 1/2 sine of theta minus phi plus sine of theta plus phi. Okay, so I'm going to use this in a second, but in order to be able to use that, I have to make sure that each side is in this form, right? So sine comes first and cosine is second. Cosine and sine, I need to flip those around, right? So I'm going to flip that around and rewrite it. So sine of 3x cosine of x equals sine of x cosine of 3x. Okay, so now I'm going to apply this identity to both sides. Okay, so on the left side, and I'm going to come out as far as I can here, 1/2 sine of the first one minus the second one, so 3x minus x, plus sine of 3x plus x, the two angles added together, equals 1/2 sine of x minus 3x. Okay, that's going to give me a negative angle, but we know how to handle that with our even and odd identities. Okay, plus sine of x plus 3x. Okay, so there we go. Now we have used our product to sum identity to, in a way, simplify it a little bit, and it's actually going to simplify it quite a bit in a second. Let's go ahead and get rid of the 1/2 on both sides by just multiplying both sides by 2. Kind of feels like cheating, but it's not, I promised, right? Did that to both sides, multiplied both sides by 2. So it cancels and it cancels. Okay, to leave me with sine of 2x plus sine of 4x equals sine of negative 2x plus sine of 4x. Okay, and then remember, we can't leave this negative in here. It would be easier if it were positive. That way it'll look a lot like this one. Okay, so I'm going to use my even and odd identity. If you remember, sine of a negative angle is equal to negative sine of the positive version of that angle. Okay, so I can actually just rewrite this all together. So sine of 2x plus sine of 4x equals negative sine of 2x plus sine of 4x. Okay, so now is typically when I'll try to get everything to one side. So I'm going to, and I'll actually write this step out, I will add sine of 2x to both sides. Okay, and I'm also going to subtract sine of 4x from both sides. And this is oddly convenient because the sine of 4x will cancel each other out. Okay, I'm left with 2 sine of 2x equals 0. Okay, everything else kind of canceled. Okay, and if I divided both sides by 2, I'm not going to write that part out, but if I divided both sides by 2, I end up with sine of 2x equals 0. Okay, and that's a double angle identity. Okay, if you can write this in terms of just a single x instead of this 2x, then do it. It makes life easier. So sine of 2x is 2 sine of x cosine of x. Okay, remember that's your double angle identity. While I'm writing identities off to the side, I might as well write this one. Sine of 2x equals 2 sine of x cosine of x. Okay, that's the identity I used there. Okay, zero product principle. I can take each individual component here and set them equal to 0. T equals 0, and it doesn't make any sense, so I'll leave that alone. sine of x equals 0, and cosine of x equals 0. Now where on my unit circle will I find sine equal to 0? Well, that'll be at 0 and at pi. And where will I find cosine equal to 0? That's at pi over 2 and at 3 pi over 2. Okay, so those are my 4 solutions. 0, pi over 2, pi, and 3 pi over 2.